do about it? What do we do about it to cost effectively save and hit those targets, hopefully get certified, and go? So that's what we're going to be focusing on today, and talking about some resources that we've developed to help in that planning process, some self-serve resources as well that you can take and run with, and one of our technical advisors, Wayne Aldridge, is going to be talking through some of those. A few housekeeping items. As usual, we will be recording the webinar and distributing that to everybody who registered a recording along with a PDF of the slides. So in case any clients or colleagues were not able to make it today, that content will still be available. Everyone, just to keep things orderly, as usual, we'll have some time for Q&A at the end. We're going to try to save 10 or 15 minutes. There'll be questions. There's a box on the right. We've switched from GoToWebinar to WebEx, some of you may have noticed. We hope it's a smoother interface. We like it so far. And so type your questions in, and we will make sure we get to all of those. I said who's presenting today, so we'll skip this slide quickly. So I mentioned the Buildings Challenge is also staffing the Energy and Water Resource Center. It makes sense. We've been doing benchmarking with the buildings we work with for over 5 years now, and work directly with DWP and SoCalGas, the Mayor's Office. So we're here to be a resource to help negate the existing buildings energy and water efficiency ordinance, EBEWE, as we're calling it, another acronym. This is a little screenshot of the website for the Resource Center. That's betterbuildingsla.com, and it's a great resource for what's required, timing. If you need help with the benchmarking process and you'd like to hire a service provider, we've pre-qualified a list of firms. All of that kind of good stuff is there, as well as step-by-step guidance for the whole data acquisition benchmarking process. So this is the diagram that shows what the ordinance says, simply as we can put it. There are lots of questions about this. Today, again, we're focusing on the energy piece. So this little box section here, the performance path, two ways to go here. We're going to talk more about energy audits and retro commissioning next year. Today, focused on cost-effective strategies to hit this bottom box, reducing your energy use intensity 15%. A question we've got a lot is how do I show that? The way the ordinance is written, it says as shown in the benchmarking tool, which is Energy Star Portfolio Manager. So you want to go a 15% EEI reduction over a 5-year period in Energy Star. So we want to make sure that that data is good. Today we're going to talk about some ways to quickly figure out what you can do in your building and some of the tools that are available through the Resource Center to support you in that process. I'll point out there is an exemption on the energy side. If you get the Energy Star plaque, if it's certified, score of 75 or above, signed off by PE, then the building is good. Just got to maintain that certification. But if you're not at that 75, 15% reduction that we're talking about today. This eye chart, what this basically says is the time period that's relevant for the whole performance piece of the ordinance. So this whole bottom half of the diagram here is dictated by the last digit of your assessor identification number. There's a way to quickly look this up on the property address online. We can help with that, but this is going to tell you what's the relevant time period, the look back for achieving that 15% reduction or getting an audit. And again, today we're focused on that reduction side. So based off the last digit of your parcel number, that's a relevant 5-year look back. What we've put together, because this can be sort of difficult to visualize, okay, I kind of get what the ordinance is saying. What does it mean for my building? So what we've come up with is a very simple 2-page energy and water savings plan. We're calling, I'm going to pull it up here in a second. Hopefully it works linking from the PowerPoint to that in this new system. But this is something that we can put together for you free of charge. Things over 100,000 feet, so larger buildings that complete data. So we can only provide accurate planning advice if the data is complete and benchmarked, so we know what options are. The request that is through the website here, and that's the address. You just click the appropriate box. If you have questions about anything else, we'll answer those too. But we will get back to you within 1 business day, and we can turn these plans around in roughly the same time frame once we've got the data from you, because we have some data about the building in order to see how it's doing relative to the 15% goal or the certification exemption on the energy side. So, without further ado, here's the top section, which I think is probably the most helpful section of this short 2-page energy and water savings plan that we can create. So we will look up the AIN for if you don't have it already, and we restate here the ordinance requires covered buildings to achieve certain efficiency targets on a 5-year cycle determined by the AIN, as we were just talking about in that table of dates on the previous slide. So this provides a snapshot of how the building is doing relative to those requirements. So based off of the information that you've entered to benchmark your building, which all the large buildings hopefully have done this year because the deadline is Friday, we can do that once we've looked through it, make sure everything looks good and complete, and we can put this together. So in this example building, the AIN ends in 0, and so here the relevant compliance period is 2018 to 2022. So that means that the projects they start next year, we can make sure that we keep good record of those and that the benchmarking is done here, because again, that he's going to be looking at Energy Star as the way of proving up that reduction over time. So we want to make sure that occupancy, hours, vacancies, type of use, et cetera, is all kept accurate as well, so that your projects are reflected there. But this building, example, has a current score of a 49. The target, we have 75, because if you get the 75, you get the plaque, you're good on the energy side. So UI and water use intensity was our currently, and this is based again off of past year's benchmarking data that's been shared with Source Center. And then we say, what does that reduction equate to? 15% for energy, 20% for water. What does that mean in terms of usage intensity reduction? So now, let's see if I can. Okay, so this is a full version of the plan. So this is the top section we were just looking at. The next section, this is all driven by formulas. We looked at CBEX, which is the same data set portfolio manager uses for purposes of comparing between buildings for benchmarking. They publish the typical end-use breakdown for electricity, gas, and water for the types of buildings. So for this example building, this is a typical building end-use breakdown for that type of building would look. And they told us what their annual spend is, and so that filters through into the table, and we can spit out what the top 3 potential electricity, gas, and water savings opportunities. So, and this is high level. This is not, at this point, really customized at all, being appropriate for the type of building that it is. So this is a planning tool that, hey, I've actually already addressed, we think ventilation systems are working very well, or hey, that makes sense. We've really, know we have some issues there. And you can see also, I think it's useful to the dollars breaking out here. So where might those opportunities be? And this is driven off of formulas and from a large data set, CBEX. And we got top 3 measures for electricity, gas, water, and then we recap basically what the diagram says, what options for complying with the performance piece of the ordinance, which then is driven by that 5-year look back based on your IN. And you've got some options. One is to do the audits and retrocommissioning. Again, we're going to talk about that first part of next year. Talked about exemption through getting Energy Star certified, or as we're talking about today, document 15% reduction EUI. Some requirements on the water side. And then we've got a section here at the bottom where we will elaborate on what the potential opportunities are. And debates are available from the utilities, because almost anything you do will be debated. We're also excited to announce next year with DWP refinements to their custom performance program and enhancements, I should say. And so all of that would be more specifically here for your building type. So that is the plan. It's used as a starting point, but then what do we do now? So that's great. You've told me at a very high level what are the types of things I might do. I may or may not agree with all of those. And what's it going to cost me, and how am I supposed to go about doing these projects? So we've developed some other resources that can be used either in conjunction with this plan if we're working together on this, or these are standalone resources that you can take and run with. So I'm going to hand it over now to our technical advisor, Wayne Aldridge, to walk through these resources, and I'm going to first open what we call our ECM guide, Energy Conservation Measures Guide.
David. What we want to talk about is energy conservation measures, and you may think that it's complicated, or you need an engineer or a contractor, but there's a lot of steps that you can take simply in-house to get an understanding of where you are and what's going to be helpful for you. So it's not as daunting of a task as you think. Simple steps that we've outlined is first to take a look at the typical energy use breakdown for your building type. This is if you don't already have your own building broken down. Then we take a look at the estimated value for each one of those steps, for each one of those types. Now, the energy use breakdown, we have a table here. It also comes from CBEX. That's the Commercial Building Energy Consumption Survey, and a national program from the Department of Energy. And this is an average that you're seeing here nationally. And there's a little section that says adjust to sets. That's the state energy system. So for California, we have a in Southern California in particular, we have a slightly different breakdown. Now, this table and this information is available to you publicly. You can check it out yourself at the Department of Energy, and we can give you this information as well. But for Los Angeles, we've simplified it a little bit for you. On average, for a typical building, you may have 20% in lighting, 15% in heating, 30% in cooling. The hot water is small, but everything else kind of counts as about a third of your use.
And this guide is a standalone resource as well, or in conjunction with the plan that I was just reviewing. So if you are a building that comes through the Research Center, you're interested in sharing some data with us so that we can help develop that breakdown for your property type, we're happy to do that. But if you prefer to go through the process on your own, completely fine, great. So you could look at this as a guide for roughly how to do that for your building.
Mm-hmm. Yeah, this breakdown will help you with this breakdown, or you can be performing some of this stuff yourself. The two step that we had was estimate the value of each category. Now, when we estimate the value of each category, you take your annual energy bill. And if lighting is 20% of your expectation of energy use, that means that if you're spending $1 million a year, you're spending $200,000 a year in lighting energy. So if a proposal comes your way that, well, we can save 25% of your lighting, you already know that that's going to be about $50,000 a year in energy savings. That way you can estimate the value of what's being proposed to you. Now, step 3 is you need to identify what systems you have in place and what the value of those systems are going to be to how much need they have for retrofit or for tuning or for just dialing in. Lighting, for instance, do you have incandescent lamps like halogen decorative lamps? Do you have incandescent lamps still in use? What about old T12 lamps in your parking garage? There's great rebates that are still available from LADWP for these old lamp styles. We get down to HVAC. What kind of HVAC do you have? You have package units up on the roof, or individual tenants or individual departments? Do you have a central plant? What distribution? If you understand what you have, you're going to be able to use the proper conservation measures. Some great savings that we need to get is not just in energy, but also in water. So you take a look at your plumbing systems as well. That includes irrigation, but also faucets, toilets, urinals. There's cooling tower programs available too, and there's some great technologies that can save a tremendous amount of water there. And there's also some great rebates available. With controls may seem like highly technical, but controls are really easy to understand if you look at it this way. You either have a time-based or a manual-based system that will turn on and off the lights when they're being told to turn on and off, or you may have an occupancy-based system where it senses the need and the amount necessary of lighting or HVAC. You may have a complete building automation system as well. These are great, but they do need to be reviewed, and we'll get into that a little bit later.
Note, again, this is a standalone tool that can be used between the property manager, engineer, the appropriate folks that know the building. We can also talk through this with you. So for buildings that, again, share the information and are on the larger side.
Yeah. So then when we get into step 4, which is selecting your ECMs and understanding what best practices are available to you, this is where you have to have the understanding of the systems. So let's say you do have a central plant, but it's an old style central plant. Well, variable frequency drives. This is a variable throttle. Rather than turning something on full blast and turning it off, it actually varies it. There are great rebates available for that as well, and it can save you a tremendous amount of energy. If HVAC cooling is 30% of your bill, and you save 10% only in energy on your cooling, that's instantly a 3% savings right off the top.
Wayne, could you talk a little bit about how this table is organized and
Sure.
kind of each column and how we come up with it and how a user might use the table for their planning purposes?
Yeah, we came up with this table, and this tool has been available for a little while, and we actually have some pricing in here that may even be lower than what's listed, as some technologies have gotten cheaper. But the table is based on a technology that can be applied to a system, first column, and what sort of energy savings you could expect from that system and that technology in the second column. Simple payback and the potential costs, these are listed and were provided by local contractors within Southern California and the Los Angeles area that were surveyed on typical costs for average buildings. So this is local pricing. The secondary benefits is actually something that you may want to think about as not just a secondary benefit, but as a primary benefit. For instance, if you're a corporate facility and worker productivity is very important to you, or worker attendance is very important to you, some of these systems may actually make you more money than they would even save you in energy. So it's valuable to look at it from a productivity standpoint as well.
I know a couple of the hotels that we've worked with have been very focused on reducing noise in guest rooms. And, adding VFDs, your air handlers and other fans can do that, and that's a huge impact on guest satisfaction. So all of a sudden, the economics of that ECM may even look better, depending on how you look at ROI. So that's the other big point that we want to draw out, is that the non-energy benefits or the additional benefits really should change, that it shouldn't be secondary, because those can be the big driver in reality for these types of projects. So this takes pretty long. It goes on a few more pages actually. Yeah. But wanted to make sure everyone understood that this is local pricing. This is real. We're going to refresh this next year because, as Wayne said, pricing of these things has come down, so these numbers should actually even improve. But as a rough cut at a planning tool to start a conversation about what could make sense for your building, this is a very useful resource. Yeah, for multi-tenant buildings, hospitals, hotels, one of my favorite energy conservation measures is actually window film. For a commercial building, not only does it dress up the look from the outside of the building, but because it blocks some of that heat that comes in from the sun, the tenants are more comfortable along the perimeter of your building, and that increases their satisfaction. It also saves you energy in air conditioning as well. So that's one of my favorites. It protects the furniture. It protects the furniture. Yeah. Retro commissioning is on the very bottom here. That is a study that's been done. Retro commissioning has been studied for over 30 years. And retro commissioning, while it's part of the ordinance, it's the ordinance because of the payback and the cost benefit. Retro commissioning can be done in-house, and you can also get an outside service. But it's something that should definitely be considered for pretty much any building. Moving on to the second page, we've also broken, this is a sample of one of the pages, we've also broken out some of the other benefits that come from lighting improvements and perhaps some installed costs for certain types of systems. We're looking at exit signs and stairwell lighting. There's a lot of different lighting programs in here. There's been a tremendous amount of development in the lighting industry, and it's something that we highly recommend that you look at. One that we shortened it down for the presentation today, but another area is automation controls. If you have an automation system, doing your own self-audit of checking, and even if you don't have an automation system, but just thermostats, checking your settings and make sure that everything is timed correctly. Walking your building in the middle of the night, maybe on a Sunday, to see what's not turning off. There are things that can be done extremely cheaply and have a fast payback because there's no capital investment. Highly recommend that you engage in that as well. And all of that counts towards the 15%. So again, we're talking about cost-effective improvements to hit that 15%. It doesn't have to be capital projects. This is operational changes, making sure stuff's not running when it shouldn't be. Commissioning, make sure that the systems are performing as designed or as best they can. That all counts towards the 15%, and that'll show up in your bills. Yeah. Now, the last step that we have for our example here in the ECM guide is to understand that these energy conservation measures may have an interactive effect. So it is important that you understand what interactive effects there are so that you don't waste money. We'll just call it the way it is. Such as lighting, particularly in occupied spaces, tend to remove heat because lights produce some heat. So it tends to remove heat out of that space, which means that you're going to be using less air conditioning in those spaces where you've improved your lighting. Now, one is that in the wintertime, if you've removed some heat, you may need a little bit more heating in the wintertime. So you may have a little bit more cost that goes up in the wintertime while you're saving air conditioning costs in the summertime. Another example is of an interactive effect is faucet aerators. If you are using efficiency water-saving faucet aerator, you'll be using less hot water, which means you're saving energy on heating that water in the first place. So there's an interactive effect there. And pumping, right? It can also on pumping because
If you have a lot of faucets, you will be, and you're pumping your own water, then yes, you'll be reducing pumping energy as well. Now, a lot of systems will pop up and say, well, we've got this huge central plant. It consumes a lot of energy. We need to save energy in that central plant. Well, if you jump right in and you work on the central plant thinking that, well, it's a big ticket item, you might be losing a little bit of money, or you might be overestimating your savings. Because if you're going to be doing a lighting retrofit, and maybe you're doing some window film, and maybe you're tuning up some thermostats, you're going to find out your air conditioning cost is going to go down anyway. So if you're doing a retrofit in your central plant, your payback is going to be a little bit longer, because if your central plant is using less energy and you had a fixed cost for a retrofit, it's going to take longer for you to recover that cost. So it's important that you pick and prioritize energy conservation measures that make sense, so that you can save capital expenditure. Often, if you spend a little extra money in one area, you'll save money in another area by not having to retrofit it or having to do a lighter retrofit. Oh, go ahead, David. Oh.
and all that is leading towards, okay, we've figured out a strategy. Mm-hmm. We understand how our end use breaks down, what we should prioritize first, and what we want to tackle. But then, how do we go about getting someone to actually come and do that work and make sure we get where we go? And so that's why we created the next tool that we're going to look at, our guide to getting great proposals. And this is a shorter document, but I love this. I think it's super important, and we see so much of the time that communication, the human side, all of this seems very technical, but it comes down to communication, the two sides understanding what the goal actually is, what we're trying to do. So
yeah, and it's a single page because it's a single concept. When you get this one concept, you'll find out that your proposals and the work that's performed in your building is meeting your expectations. And that's the key to it. What are your expectations? If you know exactly what result you achieve, what problem you need to have solved, asking a contractor to solve that problem rather than expecting them to install a system, and to get them developing the correct solution for your particular problem or particular need. So develop your request for proposal to understand what is it that I want to achieve. Then you write your RFP. You require that the contractor restate what your requested solution, what your requested result is going to be. That way there's no argument that comes down to, well, I installed the system I told you I was going to install, and it doesn't work for expectations. It's difficult to go back and say, well, this isn't what I was expecting. If you have an agreement of what exactly you're expecting, then it's easier to say, this is not what we agreed to. Now, what this all means when you put together in an RFP is that if you say, oh, I need you to put in a system, the contractor's going to say, I will put in a widget for you, and it's this model number, and it's going to have these parts, and I'll do it in this fashion using this type of labor. You think you're getting a good bid because it has everything detailed out for you so that you can understand. But what happens is at the end, if it's not meeting your expectations, it doesn't matter what they sold you. So if you get that contractor to agree, okay, understanding that you need a system that's going to deliver this result to you, going to install these particular components in this particular way so that will achieve your result. That something goes wrong and the result isn't achieved, they have to make sure that they get it working, that it gets dialed in, and they do whatever is necessary to get it to work for you. Otherwise, they risk going into breach of contract. So it's a very simple concept, but it all starts with just 4 simple little steps. Know what to ask for and what you actually want to achieve. Require that the bidders restate your need and your expectation for results, require that the bidders in their proposal that what they're delivering to you will achieve your results, and require the bidders to provide all the other materials and labor to the fullest extent so that you know exactly what you're getting, so that there are no changes that happen in the field. This substitutions. That's it in a nutshell.
So I just repeat that because I think it's so important. And one of those outcomes might be that the project qualifies for a rebate from the utilities, and putting that job of understanding the rebate programs, handling that paperwork, getting that money from the utilities, make that their job. Have even deduct it from the price of the work, guarantee it. That way, you're not on the hook. Something changes, et cetera. That can be one of the outcomes that you might want, or that whatever other performance target it is that you're looking to achieve, whether that's delivering a certain level of ventilation to a server room or whatever that is. But to give, on the flip side of that, to give some room for creativity to the contractors, to the engineers, to come up with innovative solution that achieves the goal. That it goes both ways. I think if the client focuses on what are we trying to achieve, give the technical experts room to try to meet that, and they're going to come up with creative solutions, and also maybe more cost effective. If you were going out to bid for a widget, maybe you didn't need a widget. There's a way to work it with what you have there.
If you have a need where you say, I need this room to be comfortable and I need the lighting to be productive for the people, then the contractor can look at the best solution for that need. And they can be creative, and they want to win your business. So they're not going to just pick something and throw it in. They want to make sure that they understand you're going out to anybody and asking them the same question. So they have to come up with the right solution and give you the right price because they want to win your business. So by understanding exactly what you want to achieve, rather than specifying what you want to have replaced, that's the key to getting a good performance-based spec in your RFP.
Right. And we'll also be going more into performance specifications in some of early next year's webinars, but the Department of Energy with the national labs have done a lot of work on performance specifications for really common types of technologies like trofer lighting, garage lighting, rooftop package units, refrigerated cases, plug load management devices that really set that bar for what is the state of the art. If you go out with that, then the price competition will happen. So both of those tools that just reviewed that Wayne just went through are available. Great standalone resources. In that, as I mentioned, we have Wayne and 3 other in-house technical advisors. They're available to offer up to 10 hours of customized technical advisory services. So talking about your specific case, hey, I'm looking at this or this option. What have you seen that might work well? What should I be thinking about? To qualify for that, we just want to see that there's going to be a good return for our time. We're funded by DWP and so gas to do this stuff, and so expect to happen. I think everybody, that's everybody's goal. So we need to see complete and accurate data. We can help with that piece too. Benchmarking is the first step, and a lot of you have been working through that this year, but it's going to be an annual thing. So we're here to make sure that that process is clear and done. Once done, and we see that data, we just ask some questions to help understand what you're interested in doing, who would be involved in the decision to move forward or not on a project, and how are they thinking about this? What's reasonable to do? What can we touch? What can we not touch? Constructability and access are always super key too. And then if we see that hey, there's some projects here, we can move ahead and provide that support free of charge, and we're happy to do that. And then top performers, I want to talk a little bit about the Better Buildings Challenge, plug that real quickly before we open it up for questions. But top performing buildings will be invited to join the challenge, and that's really an elite network of performing buildings where we're sharing information, we're competing in a friendly way amongst ourselves, but also with cities across the country. California and LA specifically have some of the most aggressive targets, and our building stock is the most efficient in the country, but we want to keep pushing it. And so those buildings that are really demonstrating that and showing that leadership, we want them to be part of this network. And it's a lot of fun to be part of, so we encourage you to check it out. We offer a range of additional services beyond what we've been talking about today. It really is a la carte, but part of it is also awards and recognition. That's telling the story, what's working, what is possible in existing buildings, and how to get there. So that is something that we recognize on an annual basis at our Innovation Awards, which are this for 2017 projects are going to take place in March of 2018. So with that, we'll open it up for any questions. We've got about 20 minutes.
Okay, so if you'd like to type any questions you have into the chat box.
Type any questions into the chat box, and we'll respond. I guess we answered it so well that this is all crystal clear, and everybody's great to go. So,
well, I can offer one thing that I asked quite a bit is, what are the first things I should do? What should I look at first? And depending on your type of building, it does depend on what those systems are. In an automated controlled building, you do want to take a look at your controls first and make sure they're set correctly. In an industrial building, I recommend taking a look at the roof. In a low flat building, the roof causes a lot of energy to be inducted into the building. In a tall little high-rise, the roof doesn't really matter that much, but the windows do. So there are different techniques that you can use depending on your type of building.
Well, all for attending. As I mentioned, this is our last webinar of 2017, so happy holidays, and we'll be sending again the recap and coming out with our new schedule for next year in January. So thank you for attending. Have a great holiday.